Welcome back to the study of chemistry. It is all that matters, and today we're going to be talking about calculating with significant figures. So the first rule for adding and subtracting with significant figures is that the answer must be the same as the fewest number of decimal places in the problem. So if we have the problem 231.011 plus 0.020034 plus 12.7, when we add this all together, the answer can have no more decimal places than the 12.7. So the answer has to be rounded to one decimal place. So when we add up these digits and we get down to the bottom and we end up with 243.731034, students invariably will ask, well, what do we round to? Well, there is a rule for that, so that we will all round to the same digit each and every time. And in this case, because the 12.7 only has one decimal place, our answer can only have one decimal place. It always goes to the number with the fewest decimal places in the question. So for this answer, we have to round to 243.7 because the 3 after the 7 is less than 5. So therefore our answer is 243.7. So here we're adding 37.25 plus 4.387, and when we add these together we get 41.637. And so where do we round to? Well, in the question, the number with the fewest decimal places is the 37.25. So we will round to 2 decimal places. So since the 7 in the thousandths place is greater than 5, that makes the 3 round up. So our final answer is 41.64. Now for multiplying and dividing, we're going to actually count the number of significant digits, not the decimal places. We're going to have an answer that will match the number with the fewest significant digits from the question. So if we are multiplying 12.56 times 0.023, 12.56 has 4 significant digits. 0.023 has 2 significant digits. So our answer can only have 2 significant digits. So for 0.28888, the 8 in the thousandths place makes the 8 in the hundredths place round up to 9, and therefore our answer is 0.29. So here we are multiplying 37.25 times 4.387. In both of these numbers, we have 4 significant digits, so our answer has to have 4 significant digits. And when we finish multiplying, we get 163.41575. So we only need 4 significant digits, so 163.4, because the 1 in the hundredths place does not make the 4 round up. It stays as 4, so our final answer is 163.4. So here we have a question. A student measures out 6 beans using 3 different balances, 2 beans per balance. She recorded the masses as 1.125, 1.123, 1.1, 1.0, 1.13, and 1.12. So using significant digit rules for addition, what is the total mass of the jelly beans? So we're going to first add up our 6 numbers. So we end up with a value of 6.598. Now, because the 1.1 and the 1.0 both only have 1 decimal place, what we're going to do is take that 6.598 and we only can have 1 decimal place in our final answer. So the 9 will make the 5 round up, and our final solution is going to be 6.6. 1 decimal place in the answer because 1.1 and 1.0 both had 1 decimal place in the question. Remember, addition and subtraction always the fewest decimal places from the question. So a student finds the average mass of a bead to be 0.00023 grams. She wants to find the total mass of her 1,569 beads. Now for this we're going to do some multiplication. So using the significant digit rules for multiplication, what is the mass of all of her beads? So again, we're going to do the calculations. So 1,569 times 0.00023, we get an answer of 0.35087 grams. And so what we're going to do is we're going to look at two significant digits. The 1,569 has 4 digits. The 0.00023 has only 2 significant digits. So our final answer can only have 2 significant digits. So we're going to take that 0.35087. We need 2 significant digits, so 0.35, and the 0 that follows does not round up, it stays the same, so our final answer is 0.35 grams. Now something else to notice is that the only correct value for significant digits is the 0.00023, because remember, significant digits are measured quantities, and that's in grams. The 1,569 is actually a count, a number, so therefore a number count, so therefore that could not be used as a significant digit. So here we have 4 sample problems for addition, and then there are 4 sample problems for multiplication, and you actually have a PDF available for you as part of the Sophia tutorial. So go ahead and print that out, complete the 8 problems, and then why don't you turn off the video, do the work, and then come back and see how you did. So for the first question, the answer should be 43 grams. When you add these up, there are only going to be 2 significant digits, no decimal places, because the 19 does not have a decimal place. For the question number 2, the 8,875 has only 1 decimal place, so therefore our final answer can only have 1 decimal place, 8,247.8. In question number 3, this answer has 2 decimal places for 122.32, and that is the least number of decimal places, so our final answer is going to be 246.20. And for the question number 4, the first digit has 4 decimal places, the second digit has 6 decimal places, so our answer has to be rounded to 4 decimal places, 111.527. For the multiplication and division problems, we are looking at 3 significant digits in both of the first 2 numbers, 5.40 and 3.21. So our answer can have 3 significant digits, and this would be 32.4. And remember, significant digits have to have units, so grams cubed, grams times grams times grams. For question number 2, number 3, the division number 0.421 has 3 significant digits, so our answer has to have 3 significant digits, 92.0 liters. For number 3, we are looking at 2 significant digits in 0.0065, so therefore when we multiply this out, the answer comes out to be 2 significant digits, and we round to 4.8 centimeters cubed. And for the last question, there is only 1 significant digit in the number 3, and therefore when we divide, we end up with 19 point something, but we round off to 20. The 0 here is not significant because there is not a decimal following it. So hopefully this is good practice for you in significant digits. Continue to practice, as we will use this the entire year.